Groovy Basics Part 1. This is Lecture 9 of Section 3. Let's begin. In this lecture, we will study about how we declare variables in Groovy. We will study the operators in Groovy. We will study the data types, the if, else, for enhance, and while loop. We will study about the arrays and the drawbacks, and we will study about the assert keyword. All of this followed by a quiz in the end. Declaring variables in Groovy. Variables or objects have to be declared before being referenced somewhere in the code. A simple way to declare a variable is to just place a name along with some value. For example, the following code declares a variable name called name with the value Johnny. If you want to take the value of a variable, then the $sign should be prefixed along with the variable name. For example, the following code will print "Hello Johnny" in the console. The keyword def stands for definition. Groovy has a def keyword to replace a type name when we declare a variable. So basically it means we don't really want to define the type ourselves, or that we want to change the type along the right. It is also possible to ignore the keyword def during the variable declaration. So the following code is also possible. You do not need def if a variable is declared with the scope, the static keyword, or final. So all of the following are valid field declarations. However, using the def keyword in larger programs is important, as it helps define the scope in which the variable can be found and can help preserve encapsulation. The declaration of a Java object within Groovy follows the same standard as that of a normal variable. For example, the following example shows the usage of the import statement as well as referencing Java objects within the Groovy environment. Operators. Now we'll study the operators in Groovy. All operators supported in Java are identical in Groovy. For example, the postfix operators, the unary, multiplicative operators, additive, shift, relational, equality, bitwise AND, bitwise exclusive OR, bitwise inclusive OR, logical AND, logical OR, ternary, and assignment operators. Groovy goes a step further by allowing you to customize behavior of operators on Groovy types. For example, the operator named spaceship, which is useful in comparison. Then we have the regex find, we find with the regular expression. Regex match, we get a match via a regex. Java field override can be used to override generated properties to provide access to a field. Then we have the spread operator, which is used to invoke an action on all items of an aggregate object. Then we have the spread Java field operator, which is an amalgamation of the above two. The method reference is the symbol that gets a reference to a method, can be useful for creating closures from methods. Then we have an as type operator, which is used for grooving casting, coercing one type to another. Then we have a membership operator, which can be used as a replacement for the collection.contains. Then we have identity operator it's an identity check. Since equal is overwritten in Groovy with the meaning of equality, we need some fallback to check for object identity. So is there. Then we have a safe navigation, which returns null instead of throwing null pointer exceptions. Then we have an Elvis operator, which is a shorter ternary operator. Loosely coupled data types. Groovy is a scripting language and it is a loosely typed language. What is meant by a loosely typed language is that there is no need to define the data types for the variable and for the return type of the methods. The defaults will be taken, which are very specific to the particular scripting languages. For example, in the declaration section of a class, we don't necessarily have to mention the data type as well as the modifier of the variables. The if-else statement. Groovy supports the usual if-else syntax from Java, which is that you have if followed by a Boolean expression, then we have a set of statements, then we have the else keyword, and then we have the other set of statements. The following is the syntax. Groovy also supports the normal Java nested if then else. We have an if statement, then we have an else if statement, and then we finally have an else statement. Now let's see the for loop. The for loop in Groovy is much simpler and works with any kind of array, collection, map, etc. For example, this is what the for loop normally looks like, and you can iterate over an array using the sentence for I in array. Then you can iterate over a map by using the statement for E in map, and you can iterate over the characters in a string. For example, for C in text. There's a for enhanced loop in Groovy also. What does it do? The syntax looks very similar to Java and it provides much more powerful functionality. What it does is that for every object in an iterable object, we have a set of statements that are executed. Now let's see what an iterable object is. An iterable object is usually a composite object having multiple child entries that can be iterated over. Consider the following code snippets for iterable object in Groovy. Since a string object represents a collection of characters, it can be considered as an iterable object. So is the case of a collection object. So the for enhanced loop can be used in both. The output for the previous program will look something like this. Now let's discuss the while loop. The syntax of the while loop resembles to the traditional programming languages like C or Java, which is while, and we have a condition with the while loop, and then we have a set of statements which are repeated till the condition is true. Following is the syntax. Now we'll study arrays in Groovy. Groovy supports arrays just like in Java. We only get a lot more methods in Groovy. The only thing we need to consider is the way we initialize arrays. In Java, we can define and populate an array with the following code, which is string s equals to new string, and then we can add the string with it. But in Groovy, we cannot use the syntax. In Groovy, we must predetermine the size of the array, and the array has a fixed size. That means it cannot grow or shrink dynamically. We must know the size of the array when we are defining it, like here. This put add one Groovy is a new syntax and can also be done in Groovy. Assert statement. Groovy comes with an assert statement built into the language that is able to introspect objects and provide a more descriptive output about when an insertion fails. An excellent new tool for unit testing. A regular assert looks like this. We are asserting that the array list contains Friday or not. In Groovy, the output shows the evaluation of all the statement elements. This is what the output of an assert statement looks like. It is showing the evaluation of all the statements and whether the assertion has failed or has passed. In this case, 2 plus 2 equals to 4. This is equating to 4 means this assertion is true. But we have an AND statement which says Perth is equal to the Aussie capitals. And then we have a list of Australia's Aussie capitals, and Perth is not included in that. So this assertion is false because there's an AND statement in the middle. One is true and one is false, will return into a false statement. That is the end of the lecture. Now it's time for the quiz. Question 1. Groovy has the dash keyword to replace a type name when we declare a variable. Assert, def, print, private. Question number 2. What is an iterable object? The answer to question 1 is B, def, and the answer to question 2 is an iterable object is usually a composite object having multiple child entries that can be iterated over. Question number 3. Bitwise inclusive OR has the symbol A, B, C, or D. Question number 4. What is meant by a loosely coupled language? The answer to question number 3 is A. This is the symbol for the bitwise inclusive OR. And a language in which there is no need to define the data types for the variables and for the return type of the methods is called a loosely coupled language. That is the end of the quiz and also marks the end of lecture 9. Thank you.